The dream of smart glasses that can seamlessly assist us in our daily lives has always faced a huge hurdle: a constantly dying battery. The complex AI needed to understand the world from your point of view, recognizing your actions, identifying who is speaking, or even predicting what you'll do next, demands a massive amount of computational power, which quickly drains any portable device. Here's why this is important. This energy problem is one of the main reasons we don't have truly useful, all-day augmented reality glasses yet. To solve this, researchers developed a new framework they call EgoAdapt. The core idea is brilliantly simple. Instead of having one powerful, energy-hungry AI model running all the time, EgoAdapt uses a clever dual system. Think of it as having a quick, low-energy, reflex brain and a slower, more powerful, deep-thinking brain. So, what did the researchers do? They designed EgoAdapt to intelligently decide which brain to use at any given moment. It learns a policy or a set of rules for when a task is simple enough for the low-energy model. For example, if it's just trying to figure out if someone is talking, it might realize it only needs to listen to the audio and can keep the power-intensive video processing parts of its brain turned off. This technique, where a more complex AI teaches a simpler one, is called distillation. EgoAdapt adaptively distills knowledge from multiple senses, like sight and sound, down to the most efficient pathway needed for the task at hand. It essentially learns when it can afford to be lazy to save energy. Let's explore what they found. The results were dramatic. This smart switching system was able to reduce the computational workload by up to 89% and the energy consumption by nearly 10 times. That's a massive leap in efficiency. And the best part? It achieved all these savings while maintaining, and in some cases even exceeding, the accuracy of the much larger, state-of-the-art models it was compared against. It proves that you can be both smart and incredibly efficient. So, what does this mean in practice? This breakthrough could finally make always-on personal AI practical. Imagine smart glasses that can provide helpful context all day long, an assistive device for the visually impaired that can run for hours on end, or robots that can understand human behavior much more efficiently. By learning when to pay close attention and when to conserve power, EgoAdapt paves the way for a new generation of AI that can live alongside us, not just on a server, but in the devices we wear every day. If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.